So in this video, we will review the frequency analysis page. Let's start with selecting an asset. In this case, we'll take Tesla for the year 2024 between January and December. The top graph shows the asset price, and the bottom graph is basically the fast Fourier transform of the amplitude spectrum in log scale on the y-axis versus the x-axis, the time period in days. So usually when we show these fast Fourier transform, the x-axis is shown in hertz frequency. In this case, we chose to take 1 over the frequency, which is the time period, because we hope, at least I hope, that by this way it might be a bit more relatable to you. And what this bottom graph shows is actually the frequency content of the top graph, so of this price behavior of Tesla. And what we see, so for very low time periods, which means for very high frequency, because time period is 1 divided by frequency. So we see this is the part where we have like a high frequency noise. And now under this bottom graph, we have a sliding bar, which we can choose and to move. So let's, for instance, move it to 5 days. And when we move this to 5 days, it shows here on this graph, the green area shows basically the part that is left over in the signal. So if we were to apply a filter, a low-pass filter that removes the high-frequency noise, and we were to choose a 5-day cutoff period, then we would keep everything in the green area. And so you see this is a very shaky part of the amplitude spectrum. So this is really what we would consider high frequency noise. And now let's take another example. Quick disclaimers. We do not give investment or financial advice. We are only sharing our personal opinions. Let's try, for instance, Apple. And we'll try again 2024. And here we had 5-day cutoff period. We could perhaps even consider moving it to 4-day. It also removes this high frequency. So it looks like 4 or 5 days is somewhat an interesting threshold for a cutoff period. We could try also some indices. So let's go to the indices pages, and we could try, let's have a look at the NASDAQ 100 for the year 2024. How much do we have here? 6 days. Yeah, this is 4 days. This is 5 days. So it looks like 4, 5, 6 is probably the range we would also consider for the NASDAQ 100 to remove high frequency content. Let's try another one. The Dow Jones, for instance, also for the year 2024. So 5 days is also about what seems also a good choice. So yeah, so 4, 5, 6 days is something that we could consider to remove high frequency noise. On the top graph also, you can also, if you want, superimpose simple moving averages, the 20 days in orange, the 50 days in magenta, the 100 days in yellow, or the 200 days in white. So to recap, this frequency analysis page helps us select the cutoff period for our frequency domain filter. In this case, we have seen that 5 days is a reasonable choice, and we will apply it now to the Dow Jones using the Butterworth filter, a frequency domain filter. So let's look for the Dow Jones. Let's select 2024. And let's adjust the cutoff period to 5 days. By default, it's set to its lowest value, so we'll set to 5 days. And this graph shows two signals, two lines. The light blue one is the original signal, unfiltered data price, and the green is the filtered one. So what we see is that the green is a smoother version of the light blue, but the green is delayed. You see it well here. So it means that this filter introduces some lag in with the processing of the data. So it introduces a time lag. And why is that? Because we have here implemented a specific version of the frequency domain filter, which we call a causal version. And it means that all data up to time t is being used to filter the data point at time t. So there is no look-ahead bias. Quick interruption. If you like the content, don't forget to subscribe and share the video with your network. We can also do a few other experiments. Let's take the Dow Jones from 2023 onwards until the end of 2024. And with a 5-day cutoff period, we have removed the high frequency content, but we could also increase the period to, let's say, 10 days. And you see it's getting smoother. So we start removing a bit more of the mid frequency content. And if we put it to maybe, let's say, try 20 days, this is what you get. You see, you get a really a nice smooth version of the original signal, but as we increase the period, we also increase the time lag. So this is something that needs to be considered when we use causal filters. A note about these Butterworth filters, they are widely used in several engineering disciplines, like electrical engineering, mechanical engineering, in aerospace, to filter out measurements from inertial systems, from air data systems, or vibrations to filter out, let's say, the measurements from the wings or from rotating blades in helicopters. So these filters are really very much used in several engineering disciplines. Now, on top of this green line, we can also superimpose other filters. So the simple moving average, the 20-day is in orange, or the 50-day in magenta if you want, and we can zoom in a little bit more. Let's go back to 2024, and we can let's take a period of 6 months in 2024. Here you see more the various signals that now we get. So the green line is the Butterworth, and the orange and the magenta are the simple moving averages, but we can also add the 100 days in yellow or the 200 days in white. So all of these will help you with your trading and investment. In the next video, we will apply a different type of filter called the Wavelets filter. Thank you for watching, and until next time.